Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 8, Section 4, Quadratic Equations, ax squared plus bx plus c equals 0. So if you remember from our last session, 8.3, it was still quadratic equations, but we didn't have this a here. We had x squared plus bx plus c equals 0. So now we're adding one more element. We have a number in front of the x squared. So when would we be using these kind of equations? Here's an example of when we would. At amusement parks around the country, the path of riders can be modeled by the expression 16t squared minus 15t minus 5t plus 120. Factoring this expression can help the ride operators determine how long a rider rides on the initial swing. Okay, so if we solve this equation and factor it, we can find out how long a rider rides on the initial swing. Alright, so in order to factor, in the last session, you factored quadratic expressions of form ax squared plus bx plus c, where a was just 1. Okay. In this lesson, you will apply the factoring methods to quadratic expressions in which a is not 1. Okay, and what does that look like? The dimensions of a rectangle formed by the algebra tiles are the factors of 2x squared plus 5x plus 3. The factors of 2x squared plus 5x plus 3 are x plus 1 and 2x plus 3. You can also use the method by factoring by grouping to solve this expression. Okay, so what are you going to do? You're going to apply the pattern. Okay, 2x squared, and with this 5x, you're going to have mx and then px added, and then there's your 3. So find two numbers that have a product of 2 times 3, or 6, and a sum of 5. Okay, so factors of 6 and sum of 5. So what numbers do you multiply to get 6? 1 times 6 is 6. So when you add it, it's 7. That's not what you want. You have also 2 times 3, which is also 6. And when added is 5. So bingo, that's the ones you want. You want 2 and 3. So use grouping to find the factors. So now you're going to just rewrite the 5x as 2x and 3x. Okay. So when we do that, we can regroup by 2x squared plus 2x plus 3x plus 3. And if you remember from the previous chapters, we can factor out the 2x here. You can factor out the 3 here. And you can see that you have x plus 1 in common. So you can factor out the x plus 1. So you're left with 2x plus 3 and x plus 1. Therefore, this equation here can be factored as 2x plus 3 and x plus 1. Okay? Alright, so our key concept here, when you're factoring ax squared plus bx plus c, okay, to factor a trinomial to the form ax squared plus bx plus c, find two integers, m and p, with a sum of b and a product of ac. Okay, so when you add, equals the middle number. When you multiply, equals the product of ac. Then write ax squared plus bx plus c as ax squared plus mx plus px plus c, and factor by grouping. Okay, here's an example. So you want a number when added equals negative 13, when multiply equals 30. Okay. So a lot of times you can just make a chart. Okay, product of 30 and sum of negative 13. Okay, so you have 1 times 30, but it's a negative, so one of these has to be a negative number. I mean, okay, so both of them have to be a negative number. So negative 1 times negative 30 equals 30 when added. And I don't even have to add because I know it's not going to equal negative 13. So that's not it. Alright. Next number, negative 2 times negative 15. And when added, this is going to be negative 17. Okay. Let's do our next number. You have 3, negative 3 times negative 10. Okay. When added, you have negative 13, and there you go. That's the number we wanted. So the factors are negative 3 and negative 10. So we can rewrite this as negative 5x squared minus 10 minus 3x. That's where we get the minus 3 and minus 10 from. Okay, now we are going to regroup. And you have 5x squared minus 10x, 5x is in common. Negative 3x plus 6, they have the negative 3 in common. Now you have x minus 2 factored out, and you have 5x minus 3. And there's your factored form. All right, let's try another one. You have 7x squared plus 29x plus 4. Okay, so factors of 28, sum of factors. Okay, so the factors, when you multiply, that's 28. When you add, it should equal 29. Okay, so you have 1 times 28, it's 28. When added, it's 29. So you have 1 and 28. So your m and p is going to be 1 and 28. So now it becomes 7x squared plus 1x plus 28x plus 4. They have x in common, and they have 4 in common. So that factors out. Now you can factor out the 7x plus 1, which they have in common. Comes here, and what's left is x plus 4. And now you have your completely factored form. All right, here's a study tip. Greatest common factor. Always look for a greatest common factor of the terms of a polynomial before you factor. So look for what they have in common. Okay, so here's a different method that I learned when I was learning this way back. So you have multiples of these numbers, and when added, it should be 29. So the way I learned it, you're going to use the factors of 7, which is 1 and 7. Okay, and the factors of 4, it can be 2 and 2. Okay, and when you cross multiply, that's 14, and that's 2, and when added, it's 16. So this is not the combination. And I use several trial and errors to see what I get. 1 and 7 again. So if it's not 2 and 2, it must be 1 and 4. I'm going to put the 4 up here and 1 down here, because I know when you put 7 times 4 is 28. 1 times 1 is 1. When added, it's 29. That's exactly what I want. So what am I doing with this? This combination is telling me this is 1x, positive 4. Okay. And here is 7x plus 1. Okay. It's the same answer. You factor it out. Just a different way of doing it. So if you look back here, okay, it's the same answer. X plus 4 is 7x plus 1. Okay. But it's just a different way of how I learned how to do it. And whichever you prefer, you can do. Alright, here's another example. So you can use the textbook method where you regroup and then factor. Or you can also use the method that I learned how to do. So factors of 3 is only 1 and 3. Factors of 18, it can be 1 and 18. But when you multiply and add, it is 8, 9, 10, 11, 21. That's not it. Let's try something different then. 1 and 3. Multiple factors of 9. It can be 9 and 2. So 2 and 9. Let's try that. You have 6 here. 9 here. That's not 18. Okay, that's not it. Let's try 1 and 3. How about if we switch and put the 9 here and a 3 here? You have 27, and you have 3. You add, that's not it either. Okay, let's try 1 and 3 and 2 and 9. Okay, wait. So this method will only work if you factor everything out first. So if they do have a greatest common factor, which is 3, you have x squared plus 5x plus 6. Okay. Now it's easier because you factor out the 3, and you have this. Now we're going back to our previous section. Multiply makes 6, and add it makes 3, which is x plus 3 and x plus 2. Okay. So this method only works when you have completely factored out. If they have something greatest common factor, then you factor that number out first, and then it will work. Okay, so here's your turn number 1A and 1B. Go ahead and try those two problems on a separate sheet of paper. Make sure you label it so that you will get credit for it when you hand it in for homework tomorrow. Okay, and come back when you're done. Alright, welcome back. Here's example number 2. So here you see a difference. Now it's a negative number in the middle. It's the same concept. You're factoring out. Okay, you can still use the textbook method or the method that I've taught you. Okay. So if you want to use the method I taught you, multiply and make 3, so 1 and 3. Two numbers that are multiplied, that makes 20, but added makes negative 17. So you know it's going to be two negative numbers. So let's try negative 4 and negative 5. Multiply is negative 12. Multiply is negative 5. When added is negative 17. Good. First try. Alright, so what this means, these numbers are, just put an x there and x there. Okay, that means x minus 4 and the other factor is 3x minus 5. Okay, so that is your factored form. And you can use the textbook method by regrouping, but either or, you'll still get the same answer. Okay, so I'm going to move on to some more examples here. And I personally, I like the one that, the way I learned it, because it's a lot easier. I feel like the textbook is giving you one more step by regrouping. But again, you could do either or. Alright. So first thing, what do they all have in common? You can factor out 2. So I have 2x squared plus 11x plus 5. Alright. So with these numbers, when multiplied, makes 2. So 1, 2. Multiply, make 5. 5, 1. When multiplied, cross multiplied, and added, it makes 11. So here are my numbers. And you just put an x there and x here. So you have your original 2 that you factored. And you have your 1x plus 5. And then you have your 2x plus 1. Okay, and that would be your final answer as factored. Alright, example here, you notice it's not equal to 0. So I am going to make it equal to 0 by simply adding your 2x to each, your 2 to each side. Okay. Now I'm looking for numbers multiplied to make negative 3. So it's 1, 3. It can be one of these can be negative. And then you have 1 and 2. When multiply negative 3, multiply makes it 2, that makes it a negative 1. Okay, so that combination doesn't work. Let's try negative 1, 3, 1, 2. That's 3. That makes it negative 2. That doesn't work. That's positive 1. Alright, so if I can make this both a negative, let's see if negative 1, a 3, negative 1, negative 2. So you have negative 3 and a 2. Makes it a negative 1. Okay, then let's try negative 1, 3, 2, 1. Okay, that makes it a 6. That makes it a negative 1. When I add it, makes it 5. Perfect. Here's what we need. Just add the x and x here. Okay. That means when factored, you have negative x plus 2 and 3x plus 1. Okay. And that's your final factored form. All right, go ahead and do numbers 2a and 2b. This will actually be your final slide, your final assignment. So when you're done with this, make sure you put it away in your book bag so you can get credit for tomorrow's homework. All right, thanks for watching.